You going through some of the stuff in the last couple days since class was rapid fire here, but I want to make sure we have this available online. This is going to be class from block day on Monday or Tuesday on November 4th and 5th. It's kind of the starting point of the quadratic formulas and completing the squares, that stuff from section 3.2. The first couple questions, honestly, are almost so easy they're confusing. What we're looking at here is they want you to take this equation, find its match up above with the given zeros to solve the equation. So basically, x is going to equal -4 or 3. Those are my two solutions because I'm given up above that if f of 4 equals f of 3 and they both equal 0, that those are my two solutions for 0. So x is going to equal -4 or +3. So some of us have had questions on that because they're like, what is it even asking? So hopefully we get over the fact that it's honestly just that easy. That's why it was confusing. So the next piece we're going to get into is looking at trying to graphically locate these. And so we're going to take a quick look at how do we use our calculator to find these, and you can use this in the future. So if I'm referencing towards calculator type movements in the future and finding zeros, go ahead and refer back to this. I will give you more detailed instructions here, assuming it loads here soon. I probably should have loaded this before we started the video. But we're basically going to use the calculating functions on the calculator there. We'll just go second trace and find its zeros. So given y equals, we're going to go ahead and type in one of these equations. And so in this situation, our example will be x squared plus 3x minus 5. So x squared plus 3x minus 5 is going to be our equation, and I want to know when that equals 0. So if I go back to my Zoom standard, excuse me, and most of these are going to fit inside of our standard window. Again, when you get into more complicated ones, if it doesn't fit inside the window, look at a different window, so adjust it accordingly. And here I can see both my solutions, so we go second trace, which is calc. Click on the second option, which is zeros. You'll be asked a couple questions. Left bound. Pick left of one of the x-intercepts. And then right bound, so pick right of the x-intercept. And then go in the middle, which is your guess. It will solve it for you. So that 0 is at 1.19 to the nearest hundredths. Then if you want to find the other 0, do it again. Second trace. The second option is zeros. Get a new left bound. Go left of the other x-intercept. Go right of that x-intercept, and go somewhere in the middle as a guess, and it'll tell you your other 0 is at -4.19. Okay, so that's how we can find it using the calculator, and that'll become kind of a nice, helpful tool for us in the future if we're having issues solving it with quadratic equation or any other method. So that will help you there, hopefully. Next piece is going to be solving things, just finding the roots. So if I've got something like m squared equals 16, take the square root of both sides. Okay, so undo that square. M is going to equal plus or minus the square root of 16, which is 4 in this case. So our two solutions, if you wrote it out, would be 4 or -4. Okay, so anytime you take the square root, remember -4 times -4 is also a positive 16. So you have two solutions with these quadratic equations. Then we're going to get into things where we're trying to complete the square. First couple questions just kind of help you practice it. I want to know what I need to add here so that this becomes a perfect square. In other words, what term do I add to make a perfect square trinomial so that it factors into a perfect binomial square? So these are going to be identical. And so that ultimately ends up in just a single term that is squared. And so I want to look from our factoring practices in the past. We should know that something times something, so something here times something here will equal whatever C value is, or AC if this is different than 1. And then this plus this will equal that term. Well, since we want them to be the same, it's got to be multiplied by itself. So basically, what is half of 6? Well, that's 3. So 3 plus 3 gives me 6, and 3 times 3 gives me 9. So this is going to give us, if I add 9 to that trinomial, up here, I'll end up with the perfect square binomial of x plus 3. This is going to help us when we go to actually complete the square, which we'll talk about for solving for x values here. It's actually how you derive the quadratic equation as well, and it'll help us later on when we start trying to graph stuff. So let's say I want to solve this by completing the square. We already kind of did this, so I'm going to go through a little bit quicker here. 6x plus, we talked about half of that is 3. So in order to create that perfect square, I needed to add 9. And so if I'm adding 9 to one side, I have to do it to the other side as well. So this is going to be x plus 3 squared equals a positive 4. The reason we want to do this is because now you have a square, so you can just take the square root of both sides. And so you end up with x plus 3 equals a plus or minus 2. And then we can subtract 3 over. We'll see that negative 3 plus or minus 2 will become our two solutions. If I work that out, we'll see that x equals negative 5, or x would equal negative 1. So there are my two solutions by completing the square. Next thing we're going to take a look at here, again, we're just going to solve these by completing the square and with the calculator. So go ahead, complete the square on this. You're going to want to make sure, these get a little bit more complicated. I want to get this so that we have 2x squared plus 7x equals 4. When you complete the square, I think it's easiest to make that lead coefficient, my a value, 1. So I'm going to divide everything by 2 early. And then we'll complete the square. So just to show us how this works, again, this is going to be the perfect binomial square of half of our b value, so this becomes 7 over 4. What I needed to add to both sides, so basically what did I have to add there? I needed to add the square of that, so that's 49 over 16 is what I was essentially adding to both sides. That's how I created the perfect square. And so 2 is basically 32 over 16. I'm showing my side math over there. So 32 plus 49 gives us 81 over 16 is going to be what we end up with on that side. So again, whatever I needed to add, which in this case was our 49 over 16, then I needed a common denominator so that I could add fractions. That'll give us this. So now we'll take the square root of both sides. So x plus 7/4 is going to equal 9 over 4. So again, here's that piece if we don't recall. That when you take the square root of something, it's basically the square root of the top and square root of the bottom. So we end up with 9 over 4. And now our two solutions as we work through this, we're going to subtract that 7/4 to the other side. Plus or minus that 9/4. So if we have negative 7 minus 9 more fourths, one of our x solutions will be negative 16/4, which simplifies as negative 4. And the other one would be negative 7 plus 9/4 is a positive 2/4, or a positive 1/2. So in this case, those become our two solutions. Again, if you check that in the calculator, doing that step I showed you earlier, you can go find the zeros. You should come up with those solutions as well, negative 4 and positive 0.5. Go ahead and test those and just kind of make sure that that works. This is kind of additional practice. Next piece here is solving these with the most efficient way. So sometimes it's easier to factor, sometimes it's easier to use this completing the square, and sometimes it's easier just to go right ahead and plug it in to the quadratic formula. For these two examples, I'm going to get this stuff on one side real quick and see if it's factorable. I think factoring is the fastest way if it's possible. And so in this case, do I have something that multiplies to a negative 18 and adds to negative 3? And hopefully our math facts, we go, oh yeah, that's a negative 6 and a positive 3. So we see that this factors quite easily into those two factors. Quickly recalling, now we're going to take each factor and set it equal to 0, because 0, if I make this 0, times anything is going to be 0. So this will be x equals 6, and this will be x equals negative 3. That would be our two solutions to make this entire thing equal to 0. So in that case, factoring was pretty quick and easy. This side, I don't see anything that's going to multiply to negative 1 and add to a positive 6, but my b term is divisible by 2, so I don't have to deal with fractions. I think completing the square might go pretty quick here. So I'm going to have w squared plus 6w plus something is going to equal, I'm going to add that 1 over, plus that same something I add here. So that perfect square I'm looking for is going to be, in this case, x plus half of 6. Oops, not x, we're using w right now. Excuse me, my eraser is tweaking out here. Okay, so we're going to use w plus 3. And so in order to create that perfect square, we needed to add 9 to both sides. So see, this w plus 3 squared will equal 10. Take the square root of both sides. We'll see that w plus 3 is equal to plus or minus the square root of 10. And so your final two solutions are going to be w equals negative 3 plus or minus the square root of 10. Okay, and if it asks for you to get this rounded to the nearest hundredths, okay, again, type that into the calculator. You'll have negative 3 plus square root of 10, which is going to be like 0.2 or something like that. And then negative 3 minus radical 10 is going to be like negative 6.2 or something like that. So go ahead, type those in, get the nearest hundredths for you. And then we'll take a look at the next piece. So there's a bunch of those. Not every single one is going to be solved the exact same way. Again, look for what's the most efficient way so that you don't have to take the forever long route on trying to solve these. Okay, next one, we're going to talk about the discriminant a little bit. Discriminant is that value that's underneath your square root in the quadratic formula. So it's that b squared minus 4ac part. Okay. So again, if you don't recall the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this piece. Why that's important to us is we can't take the square root of every number and get a real solution. So our discriminant, this b squared minus 4ac, is going to tell us a lot. If it's greater than 0, I know that I've got two real solutions. If it's less than 0, so if this is less than 0, I know that I have two non-real solutions. So basically, if it's less than 0, it's a negative number. So I'm going to have imaginary numbers. So you'll get a plus or minus some number with an I value. And then the other thing that's kind of unique is if it's actually equal to 0, you're going to get one solution. And it'll be real. One solution that's real. And hopefully that kind of makes sense because you're plus or minus 0. That essentially means you've got something where you're coming down, you're going to touch, and you're going to head back up. So that solution is the only one you have, but it happens twice. When we go to graph stuff later in the year, in another month or so, we'll talk about having multiple zeros, the multiplicity of a 0, and we'll see how that makes that balance effect happen universally. So you're going to use that information to describe how many solutions I've got. Do I have solutions? Are they real? Are they integered values? And those sorts of things. That's what those questions are actually asking. Next one, you're just going to simplify and solve. So we've already talked about that. We won't spend any more time on it. And then we're going to get into a couple other unique looks where you're going to be able to solve these x-intercepts and then be able to identify and talk about what's going on with the graph. So in this particular case, I want to know, when is this function f of x equals negative x squared plus 4x? When is this greater than 0? And so if I factor this, so first of all, let's see when it actually is equal to 0. So I can factor out a negative x. I'm left with an x minus 4. So my two x-intercepts, when I solve this, is going to be x equals 0 for this first part. And then x equals a positive 4 for the second part here. If I think about it graphically, I know that that lead coefficient's negative. And so I'm going to have that frowny face parabola, so to speak. Somebody might have taught you it that way. Okay, so it's that downward facing parabola. And so now I know kind of what it looks like. And if I want to double check, is that actually true? Go ahead, plug in x equals 2. So 2 squared is 4, negative 4, plus 2 times 4 is 8. So negative 4 plus 8 is positive 4. So we have that point up here, which is actually at the coordinate point 2, 4. So that'll kind of just double check, make sure you built that correctly. And I want to know, is this greater than 0? And so you're like, oh, well, I'm greater than 0 inside that spot. And so your solutions here are going to be where x's are between 0 and 4. So if we go back to our interval notation stuff, we can talk about x being an element and talk about that range of numbers where I'm greater than 0. Okay? The last piece is it'll talk about the interval test method. And the interval test method is going to be very similar, but instead of looking at the graph and being like, oh yeah, visually that makes sense, you'll be able to take a look at it and say, oh, let's test a point. Is it true or false? Because I know it either needs to be between those 2 points, if it's inside that hump or valley, or it's got to be the tails. And so, again, let's take a look at something like this. I know almost instantly that my two x-intercepts for this, if it was x equals 0, my intercepts are going to be at negative 3 and a positive 1. And so graphically, again, what we're going to see is we've got negative 3 and a positive 1. And I know I can either be true in between these or off on the tails. Okay, so I'm going to check a point. I'm going to pick one in the middle, call it 0. If 0 is substituted in for my x, I get 3 times a negative 1, which equals negative 3. Is negative 3 less than 0? Yes, it is. So I'm going to assume that that's going to be true. Okay, so my solution set should be x is an element from negative 3 to positive 1. Okay, again, if we want to double check this, we can think about it graphically. That's a positive lead coefficient if we factor it out. So this should be our happy face or the upward facing parabola. And sure enough, I am below 0 in that little valley there. So hopefully that makes sense. That's kind of the start of 3.2. And then I'm going to go on to talking about the story problem stuff in class from today on Wednesday, 11/6, in the next video. Good luck.